Muller and McDonald challenged the conventional theory for the cause of glacial cycles in 1995, according to the Milankovitch theory, where the 100,000-year glacial cycle is attributed to changes in insolation, that is, solar heating, brought about by variations in the eccentricity of the Earth's orbit. They noted serious theoretical difficulties with this concept because insolation variation are too small to drive the cycles, and a predicted strong 400,000-year modulation is not present. They further pointed out that there are specific disagreements between a strong glacial cycle at both 400,000 years and the present times when the eccentricity modulation is near zero. This conflict is also called Stage 11 problem. In addition, improved measurements have uncovered an apparent causality problem. The sudden termination of the glacial cycles appear to precede the increases in insolation. Although this interpretation has been disputed, they suggested that a radical solution is necessary to solve these problems. Muller and MacDonald propose that the 100,000-year glacial cycle is caused not by eccentricity, but by the previously ignored parameter orbital inclination, that is, the tilt of the Earth's orbital plane. Muller and MacDonald simplify the cycle intervals to 100,000 years and 400,000 years, although they vary in duration, as shown in Berger et al. For interglacials of the last 800,000 years, and in the graph presented here from a report by Cornett comparing notes between Triassic and Jurassic Milankovitch climatic cycles and Pleistocene cycles in Berger et al. 2015. In the new theory presented here, we concur with Muller and MacDonald that orbital inclination has been overlooked, but more importantly, we propose that the Earth rotates on its orbital axis, formerly precession axis, during an ice age, but stops rotating on that axis during an interglacial period. This shift in rotation provides a unique explanation for orbital inclination and requires an additional mechanism for stopping orbital axis rotation when the Earth's orbital plane is closely aligned with the Sun's ecliptic or accretion disk. In order to accomplish this periodic transformation and alteration in Earth rotation approximately every 108,000 years, with shorter interglacial cycles of 21,600 years, a mechanism is proposed that involves a slow wobble of the Sun, such that its accretion disk regularly seesaws above and below Earth's orbital plane, just enough to free the Earth from the rotational braking caused by the alignment of Earth's orbital plane with the accretion disk. It is therefore necessary to propose an astrophysical explanation for why the physics within the influence of the accretion disk causes rotation of matter in the plane of the ecliptic to be retarded or stopped. The Coriolis force above and below the ecliptic is opposite, but cancels out movement perpendicular to the direction of rotation of the axis of rotation of the Sun within the accretion disk. Muller and MacDonald propose that the use of oxygen isotope ratios, one can determine the percentage of Earth's water that is frozen in ice. In the diagram shown here, they compare orbital inclination, solid line, lagged by 33,000 years, with delta oxygen-18 isotope climate data, note the dotted line, for the last 600,000 years from the SPECMAP compiled from data from 5 seafloor cores. Their figure also shows the orbital inclination, I, solid line, calculated by direct interpretation of planetary perturbations, which was transformed to the invariable plane, the plane of symmetry of the solar system, and shifted to give the best least squares fit to the delta oxygen-18 data. They state that only 3 parameters were adjusted, 1 for the delay and 2 for the overall scale for the best fit. I preceded delta oxygen-18 by 33 times 3,000 years. Since this is positive, there is no causality problem. Similarly, the presence of a strong variation in I near 400,000 years solves the stage 11 problem. The existence of the 100,000-year cycle of orbital inclination does not seem to have been previously noticed by climatologists or astronomers. It may have been missed for two reasons. Ever since Milankovitch, the implicit assumption has been that insolation is the driving force for climate cycles, and insolation is not directly affected by orbital inclination. Secondly, the 100,000-year cycle is not evident when I is calculated in the usual reference frame based on the present orbit of the Earth. Only when transformed to the invariable plane or a plane near it does the 100,000-year cycle unmix from the obscuring effect of a strong 70,000-year orbital precession cycle. We note that the 70,000-year cycle has been reported in delta oxygen 18 data from other sedimentary samples, and we suggest that this cycle may be related to orbital precession. The only mechanism we have found that could link orbital inclination to climate is extraterrestrial accretion of meteoroids or dust. Such material can be detected in ice and sedimentary rock through analysis of iridium. Walter Alvarez has pointed out that extraterrestrial dust cycles could be detected using helium-3. If this mechanism is correct, then the 100,000-year cycle should be seen in ice and sedimentary records of extraterrestrial accretion. C.F. Imbrie et al., 1984 and 1993.
To proceed with this video, go to Part 2.